Okay. Are you able to see my screen, Fred?
Yeah, I can see the white screen.
Yeah, now I'm gonna write something up here and tell me if there's any delay.
Yeah, it's like maybe a 2 or 3 second delay, but nothing like the other day.
So
Was having a problem.
so it's better. Okay, well let's go with it, and then if it gets bad, I've got something running in the background because what I like to do is convert these to YouTube right away rather than waiting on them archiving. And if that ends up slowing us down again, I won't do it. I'll do something different. Oh,
Okay.
all right. So now
Recording started.
let's talk about VLSM. VLSM stands for Variable Length Subnet Mask. And the idea is real basic. Let's say we start out with an address range, like I'll just pick one. I'll do 172.16.0.0/16. Do you understand what I just wrote down? Do you understand what that means?
Hello?
Hey Fred, do you understand what that means? This 172.16.0.0/16. Have you gotten that far in your reading where you understand what that means?
Yeah.
Okay, so this is a /16 address, and basically what I'm going to do is I'm going to show you a sample of why I would need VLSM. So let's say I had a scenario where I was connected to some network. Let's say I was connected to the corporate network. And in my division I had a routing device that was connected to the corporate network. And the corporate network has assigned me this 172.16. They've given me this address block to use, right? So now what they want to know is, or what they've given me is this address block. And now let's say I've got several divisions in my organization. So let's say I've got a network in which I have well, we'll just say this. I come in here and I've got another router, and I've got another router, and I've got another router, and another router, and we'll go with another one. So and then let's say each one of these has maybe a LAN off of them, right? So this is a network, and let's say this is my marketing, and let's say marketing has we'll go with 10 computers, and then we have finance, and let's say in the finance department we have 10 computers. And then over in this division, we'll say this is sales. And let's say sales has 200 computers. And then we've got over here, we've got, let's say, our staff. This is our staff computer network. And in the staff computer network, let's say we have 1,000 computers. And then in the and let's say we have another one. We have partners. We have a partner network. And let's say the partner network's big. Let's say the partner network has 4,000 computers. And then of course we have to create an address scheme to where each one of these interfaces between the routers, they are only going to require 2 IPs, right? We're only going to require 2 IPs in between each of these routers. So only 2 IPs are going to be required in between the routers. So we now have a need for a network with 4,000 some hosts, a network with 1,000 some hosts, a network with 200 some hosts, a network with 10 some hosts, a network with 10 some hosts, and 4 networks with a bunch of 2s, with a bunch of only 2 IPs. So the question now becomes, if we were just using plain old CIDR, as we've learned before, subnetting, if we were just going to do using CIDR subnetting, then we would have to create a subnetting scheme that would handle the largest network. So in this case, the largest network is 4,000 machines. We would have to create a block that would give an address. So let's just figure out what that would be real quick. So in order to get to 4,000 hosts, I would have to take 2 to the power of some number to get to something about 4,000. Do you happen to know what that is, Fred?
Not offhand.
Okay, so I'll give you a hint. Let's just go through this. 2 to the power of 10, 2 to the power of 6 is 256, or no, 2 to the power of 8 is 256, right? 2 to the power of 9 is 512. 2 to the power of 10 is, 2 to the power of 10 is 1024. 2 to the power of 11 is 2048. 2 to the power of 12 is 4096. So in this case, we would require 12 bits in our host section of our address in order to accommodate this. So let's just figure that out real quick. Even though we're not going to use it, I want to show it to you just so you understand it. So we need 12 bits. So I would have to have 0. I'm going to need more room. I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these would be considered my host bits. Host bits. And that is 2 to the power of 12, which is 4096. Which gives me the largest network I would need, which is my partner network down here, right? So the rest can now be ones. 1, 2, 3, 4. So here was my original /16, and I can extend by 4 bits. The rest have to be hosts. So in the classic subnetting role, I would go from a /16 to a /20. That would give me 2 to the power of 4, or so 2 to the power of 4, which would be 16 subnets. So 2 to the power of 4 is 16 subnets. So I could have 16 subnets, all with 4,096 hosts per subnet. Now, would this work for my scenario? Well, I need 1 here. So this would be 1, 2. So let me count them. I need 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would work, right? I need 9. I have 16. That would work out. But assigning 4,096 available, or 4,094 available IP addresses for the marketing department looks like a little wasteful to me. Does that seem wasteful to you, Fred, to assign 4,000 IP addresses to marketing? Yeah, because marketing only needs 10, right? So in the classical subnetting scheme, it makes sense, but the problem is I end up assigning way too many addresses to networks that are smaller, so I need more flexibility. So VLSM is all about flexibility. Being able to assign different lengths of a subnet mask depending on the size of the network. Do you understand the concept behind this?
Yeah.
So
Coming in.
now, we now know that for my 4096 network, I need, my lights just turned off. There we go. All right, so I know that I need 2 to the power of 12, which is 4096. So I know I need, and we just learned what that is. If I need 12 bits, I need a /20. So I know that that has to be a /20. Right? So just to show that mask out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's my original /16. I would extend by 4 bits, 1, 2, 3, 4, and I would leave the rest as zeros. Right? This being that 12 right here. Right? So that is the mask I need. I need a /20 to accomplish 4096. So the /20, right, would help me for the partner network down here. For the staff network, which only needs 1,000, then I would only go 2 to the power of 10. So in that case, I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would need 10 available bits in the host field. So here's my original /16. I could then consume 6 additional bits, and I would need 10 host bits. So that would be 1024. 2 to the power of 10 is 1024. So in this case, I would need a /16, 17, 18, 19, 20, 21, 22. I need a /22. So down here in the partner network, this is going to be a /20. This is going to be a /22. Do you understand how I got that?
Yes.
Okay, so let's continue on. Now I need to figure out what slash I need for my 200 networks. Right? So what do I need for my 200 networks? Well, 2 to the power of what is greater than 200? Well, 2 to the power of 8 equals 256. So in that case, I'm going to need 1, 2, 3, 4, 5, 6, 7, 8 bits in the host field. The rest can be reserved for subnets. So here's my original /16. 16, 17, 18, 19, 20, 21, 22, 23, 24. So I need for my 200 network, my 200 host networks, I need 2 to the power of 8, right? In my host bit field, notice I have 8 bits here, right? I have 8 bits here. So consequently, I can extend to a /24. So in the sales networks, I'm going with a /24. In the finance and marketing, I only need 10. So what 2 to the power of what gets closer to 10? Well, 2 to the power of 3 is 8, so that doesn't work. 2 to the power of 4 is 16. That works. So in my mask, the last 4 bits are going to be reserved for the hosts so that I can get to 16 to at least 10. The rest can be marked as 1s for subnets. There you go. So I got 8, 8, 8, and then 4. So this would be 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So for the networks that have 10 hosts, I need 2 to the power of 4. In this case, I can extend all the way to a /28. So these networks will be a /28. Are you with me?
I'm right here.
All right, so according to this and what we just figured out there, right? I need a /28. I need 2 /28s. I need a /24, a /22, and a /20. This is called variable length subnet masking. So what you do is you start with your main address, 172.16.0.0. And here is the thing that you must always remember about this. Right? You ready? This is a secret I'll give to you and only to Fred and whoever else bothers to watch this video. So here's the secret. You always start with the largest host network when creating a VLSM scheme. Always start with the largest. So, what is my largest here? It's the partner network. Yeah, you're right. The partner network right here. That's my largest. So I'm going to break this 172.16.0.0 into a bunch of /20s. So I'm going to make them into a bunch of /20s. Now going from a /16 to a /20, how many bits did I extend by?
4.
4, right? Well, 2 to the power of 4 is what? 16. So I know that by going to a /20, I'm going to create 16 subnets. Right? So let's look at that mask real quick. We know it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So a trick I've taught you in a previous video was in order to go up in increments, in order to determine what the next network ID is, we know that 178, so we know that our first one, our number 0 subnet is going to be 172.16.0.0. We know that's our first one, but what's our next one?
172.16.0.
It's not .0. So in this octet, we're going to go up in increments of 2 to the power of the number of host bits. So in this case, we have 4 host bits. So we're going to go up in increments of 2 to the power of 4, which is 16. In this octet, we're going to go up 2 to the power of, how many host bits do we have? 8. So we're going to go up 2 to the power of 8, which is 256. So this side is going to go up in one whole octet of an increment, and this is going to go up in increments of 16. So the next network ID is going to be 172.16.16.0 because 0 plus 256 in binary would be all zeros here. Right? Because you can't represent 256 with this octet. You can only represent up to 255 with this octet. So you're going to go up in increments of 256, so it's not going to allow you to represent 256 with that number, so you're just going to put 0. Right? So the next one would be what? 172.16. You're going up in increments of 16, so what's the next one?
32.
32. Dot, and what would we put here?
Is still 256.
Yeah, so 0 plus 256 is, in this case, you got to go to the next octet, so it's 0. Do you understand that? I cannot represent 256 with 8 bits. 256 is actually 1.00. 256 is 1 with 8 zeros. So we cannot represent in this last octet the number 256. So it's going to always be zeros. Do you see that?
Okay.
Remember, because this is the 1's column, 2's column, 4's column, 8's column, 16's column, right? 32 column, 64, 128 column. Notice I never mentioned 256, right?
Okay.
So we're unable to represent 256. So in this case, we're going to just go up in zeros the entire time because there is no subnet bits in this octet. All right? Now, what's next?
So you would go all the way up to 16 and going up 32.
Yes, so we would need number 3 would be, we would keep going up in increments of 16, right? So 32 plus 16, what is that?
That was 48.0.
Yep, you got it, right? And so we would keep going, right, until we got all the way up to 16 of these numbers. So what's 48 plus 16?
64.
Right? And we would keep going. What would be the last one? Do you have any idea?
I would just keep adding 16 till I got to. Now you have 15 there.
Well, because we start with the number 0, right? So in order to get to 16, right? So what's 256 minus 16?
Is 2.
That's our last one. Follow me?
Yeah.
All right, so we're going to come up with 16 of those. So what we're going to do is we can pick one of these. It doesn't matter which one we pick, right? But we're going to pick one of these. Let's pick this one. And we're going to assign this one to the partner network. So these guys down here are going to now become 172.16.16.0 on a /20. I've now created the 4,000 host network for the partners. Did you understand that, what I just did there?
Okay, yeah.
Now, do I want to assign the next one to staff?
Yes, because that's the next highest.
No, I don't want to assign the next one to staff because it's too big. Remember, this one is going to create 4,000 hosts per network. And how many hosts per network do I need in staff?
1,000.
So I only need 2 to the power of 10 in the host field, right? So what I'm going to do instead is I'm going to take this number 2 and I'm going to break it up into another level. Okay? So we're going to go down here and I'm going to take number 2 which is currently on a /20, and I'm going to break it up into a bunch of /10. Break it up into a bunch of I'm going to break it up into some more, right? So how many do I need to get to a /10? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the rest can be ones. Right? So here we go. 8, 16, 17, 18, this was my original /16. I extended 4 bits to produce this network right here. And now I'm saying that I can extend another 4 bits, right? Actually, I made a mistake there. Hold on. We've got a mistake.
22.
Yeah, I've got a mistake here. One, 2, 3, 4, 5, 6, 7, 8. Dot 9, 10. Then I would have 2 ones. There we go. So I blew it. So there we go. All right, so there we go. So here was my original /16. Here's my 17/20. Now I'm saying I can go 2 more bits, right? Do you see that? So I can convert this /20 to a /22. So that's what I'm going to do is I'm going to take this /22. I'm going to subnet that by 2 more bits. 2 more bits. I'm going to take the /20 and make it 2 more bits. By extending 2 more bits, 2 to the power of 2, how many subnets am I going to create? What's 2 to the power of 2? 4. You're right. So I'm going to create 4 subnets. So I'm going to call my first one, I'll call it 2.0. And this one is going to be 172.16.32.0. Right? That's my first one. Now I'm going to ask myself, I'm going to go to the next one, 2.1. So what's my next one going to be?
You're going up by 4s, correct?
Well, yeah, so we got to look at this. I'm going up in increments of, you're right, how many host bits do I have in this field? I have 2 to the power of 2. I'm going to go up in increments of 4. So my next one will be 172.16. What? 36.0. And 2.2 would be 172.16. What? 40.0. And 2.3 would be 172.16.44.0. Do you see that? Now we're going to stop there. The reason we're going to stop there is I'm only creating 4 subnets. And the other reason, if I added 4 more, what would I be at? If I added 4 more, what would I be at? 172.16 dot what?
88.
No, 48. Right? If I went to the next level, it'd be 48, right?
Okay, yeah.
I can't go to 48 because 48 is my next level, my next parent address. Do you see that? So I can't do that. So now what I'm going to do is I'm going to take one of these and I'm going to assign this to the staff network. And it doesn't matter. I could pick this one or I could pick it doesn't matter which one I pick. So now this one is going to become 172.16.36.0 on a /22. Do you understand how I got to that?
Yes.
Is it making sense?
It's clicking in, but what's the other 3? Because you made 4.
Yeah. They're just reserved for future use, or I can use to make another level out of them. So in this case, what's my next network I need to make?
That was 1,000, so the 200 sales.
I need to get to the sales group, so I need to make a 200. So I'm going to take this, I'm going to go down another level with this one. Right? So now I'm going to go down here to my number, I'm going to take number 2.2, which was a /22, and now I'm going to convert that to a bunch of /24s. Do you see that? So looking up here, I was on a /22. I'm going to go ahead and make these binary, right? I'm going to extend this 2 more bits. How many networks am I going to create? I'm going to create 4, right? Because I'm extending by 2 bits. And each one of these is going to have how many hosts in them? 2 to the power of 8 is 256. So I'm going to create 4 networks with 256 IPs in each of those subnets. So the way I do it is I'm going to go number 2.2.0, and that's going to be my first one, 172.16.40.0, right? And that one is current, and I'm going to make that on a /24 now. So I'm going to go up in increments of, what am I going to go up in increments of?
4?
No, because that's how many subnets I'm creating. I'm going to create 4 of these networks. 2.2.0, 2.2.1, 2.2.2, 2.2.3, right? I'm going to create 4 of these. So I've gone up in 2 to the power of 2 is 4, right? I'm going to go up in increments of the number of host bits. So 2 to the power of 8 is 256. So I'm going to go up in increments of that. Well, I can't do that, so I have to spill into the next octet. How many host bits do I have in this octet? How many host bits do I have?
It's 0, right?
Yeah. 2 to the power of 0 is equal to... Going back to early elementary algebra, 2 to the power of 0 is 1, right?
Okay.
So we're going to go up in increments of 1. So what's my next one going to be?
16.41.
There you go. It's beautiful how it works, isn't it?
Great.
Math is so simple. It's like awesome, all right? So here we go, 172.16.43.0, right? Now, why can't we go to another one? Why can't we go to 44?
That's your, well, that's the above last network.
Yeah, you're right. I can't go into the next network, right? So it all works out. So these are my 4 networks. So guess what I'm going to do? I'm going to take this one, and I'm going to assign that to sales.
Now, can you just choose anyone?
You can just pick any one. It doesn't matter. Now, when you're taking the test, the packet tracer, it'll tell you pick the first one or pick the last one or pick the second one, right? It'll tell you. It doesn't matter which one you pick. You can pick any one you want. The important point, as a network administrator, I got to stay organized about it, right? Because let's say my boss calls me tomorrow and says, hey, Guy, you remember how you created that sales subnet? Yeah. Well, I need you to add East Coast and West Coast. Ah, damn it, right? Well, I can take this one and make it East Coast, and I can make this one West Coast, right? Because I've given myself room to expand. So that's the hard part of being a network administrator, is staying flexible and agile so you can respond to the demands of corporate management. So now I'm going to take, and now I'm going to give sales, I'm going to say, okay, that's 172.16.41.0 on a /24. I've now figured out the sales subnet. Now where am I going? What do I need to do next?
You got the 210.
So I could, if I wanted to, I could go up and pick one of these. I could go all the way up to the top level, and I could say, you know what, this 48.0, that's going to be broken up into all of my slash whatevers, right? Or I could go down in this level, and I could pick one of these, and I could make this one of my lower levels. Or I could just keep going with where I'm at. I could take this 42 one right here, and I could make this one a new level, right? Which is what I'm going to do. So I'm going to take 2.2.2, which is 172.16.42.0, which is currently on a /24, and I'm going to say, you know what do I need to get to? Well, I need a bunch of /28s. Do you see that? And the reason I need /28 is because I need to get down to 16 hosts per network so I can accommodate those 10s. So, all right. So if I need 1, 2, 3, 4, 2 to the power of 4, 2 to the power of 4 is 16, which is greater than 10, which is what I want. The rest can be 1s. So here's my original 16. Then I went to a /20. Then I went to a /22. Then I went to a /24. And now I'm going to a /28. So 24 is becoming a /28. How many bits did I extend by? 2 to the power of 4, which is 16 subnets. So I'm going to create 16. My first one is going to be 2.2.2.0. And that one is going to be 172.16.42.0. And now I'm going to go up in increments of, I'm going to go up in increments of what? Well, how many host bits do I have here?
4.
2 to the power of 4 is 16. I'm going to go up in increments of 16. So 2.2.2.1 is going to be 172.16.42. 16. There you go.
Oh, okay. It threw me off, but I see we're in the 4th octet.
Yeah, we're in the 4th octet now because we're at a /28.
Yeah.
If you get this, Fred, you will be the only, I can guarantee it, you will be the only former truck driver and barbecue owner in the history of the country that knows VLSM. I can guarantee it.
All right.
I can almost with a surety guarantee you there is not another beast like that. So what's our next one?
42.32.
You got it. Awesome. And then our next one,
It'll be 16 plus the 32, 48. Now the 2.2.1, that's just to keep the order for you?
that's just that's my personal convention for keeping the straight. So I know that this is a 4th level VLSM.
Oh,
First level, second level, third level, 4th level, right? These are only 3rd level VLSMs,
yeah.
right? That's my convention for keeping this straight. And most network guys use the same convention. It's pretty common. I'm not alone in using that. I think most people do. So what's my next one?
64?
You got it.
Yeah.
And my last one would be 2.2.2.15. And what would the last one be?
240.
240. You got it. All right, is this making sense?
It's plus the U2 after this. I think it will.
All right, so I can't go to 43, right? Because if I go to 43, I'm getting into my next network, right?
Yeah.
So now what I do is I'm going to take this, right? This new /28, and I'm going to assign this to finance. And this one's going to be assigned to marketing. Do you see that? So now I'm going up here, and I'm going to give this guy 172.16. Where were we at? 42? 42.16/28 to finance, and 172.16.42.32 to /28 to marketing. Are we done yet?
What about the routers?
Yeah, very good. What about the routers? And the routers require what? The routers require only 2 hosts. So let's figure that out. Well, 2 to the power of 1 is 2. Would that work?
Yeah.
No. Because we need a network ID and a broadcast ID.
So 4.
So we need to have 2 bits, right? Minimum is 2 bits. 2 to the power of 2 is 4, so that would give us enough. The rest can be 1s, right? So we were at a 28, which is 25, 26, 27, 28. Now we need 1100. So we're going to go from a /28 to a /30. And /30 is the lowest you can go, by the way. So let's say I take this one right here and I make this a new level. So we'll take our 2.2.2.3, which is 172.16.42.48, right? And that was on a /28, and we are going to extend it to a /30. How many bits did I extend this by?
2.
2 to the power of 2 is 4. So I'm going to create 4 networks. 2.2.2.3.0, 2.2.2.3.1, 2.2.2.3.2, 2.2.2.3.3. Now, if anybody heard this conversation, perhaps the moderators listening to it, the captioning people listening to us would think we're insane, right? 2.2.2.2, right? But it makes sense because we've created now 5 levels of VLSM, right? So we've got 2.2.3, and we're extending this. We've created 4 new networks. So you tell me, how many bits, if our last octet looks like this, how many addresses are we going to go up in each network range? How many host bits do we have?
2 host bits to the power of 2, which is 4.
So we're going to go up in increments of 4. So our first one would be 172.16.42.48, and now we're going to go up in increments of 4. So our next one is what?
42.52.
You got it. What's our next one?
56. Dot 60.
Now we can't go up 4 more, because if we did, guess what?
Yeah.
So now we can take these networks and we can assign them to our network. So I can now go, all right, I'm going to assign the first one 172.16.42. What was it? 48 or 50? I can't remember.
48.
48. 48/30 to this network, right? And by the way, this router would get 49, and this one would get .50. Do you see that?
Yeah.
So then the next one, 172.16.42.52/30, would get assigned to this one. And this guy would get 53, and this guy would get 54. And then I would go 172.16.42.56 to this one /30. And then this one would get 172.16.42.60/30, and that will get assigned to this one. Boy, it worked out perfectly, didn't it?
Yeah.
If I had one more router network, I would have had to come up with another. I would have had to go VLSM out another block. But you see that? If I didn't have enough in here, see, if I didn't have enough, let's say I needed 5, right? I'd have to go take this one and break this one out too.
Okay.
But now every one of these, every machine in this network is now going to have a different subnet mask, right? They're all going to have a subnet mask based on whatever slash they're in. But the point is, Fred, this is the critical point. This router right here will only be advertising to the corporate network the following block. So this router, in this router's routing table, it'll only show 172.16.0.0. And it'll say, in order to get to 172.16.0.0, send it to this router. This router will know what to do with with all the addresses. So we don't need to what's that?
Because it's the first router.
Yeah, the first router that gets the packet will know where to send it based on the VLSM scheme. And this is what your next class is. Net 101 starts getting into how do we do that, right? Net 101 talks about how do we set up a routing protocol to communicate this information between all these routers, right? We start talking about, all right, now that we've got this little scheme, how do we get these guys to share this data, right? So that's something we have yet to talk about, but we will. All right, that's VLSM in a nutshell. Any questions for me?
I got tons of questions, but how soon before you ending? Will this be on YouTube or?
Hold on, let me stop recording and I'll chat with you.
Recording stopped.